Okay guys, so this is another ER, and this ER is actually for my final computer hardware exam. So we had 2 hours to complete this exam, and we were given a bag of parts, an ATmega 328P chip. It's the chip found in an Arduino. The chip had all the code we needed already on it. So we just had to breadboard the circuit with the parts given to us, and then we had to solder those parts onto a pre-etched and pre-drilled PCB so that we had a standalone circuit. The circuit we were trying to make was a memory game. So this is the final product, and what it was this bicolor LED would flash 4 times, and it would either be red or green each time. So it would flash, say, green, green, red, red. And then you had to remember the sequence that it flashed in and set these 4 bicolor LEDs to the same sequence. So if it flashed green, green, red, red, I would set it to be green, green, red, red. When you think you set it to the correct sequence, you would then push this switch to lock in your answer, and if you're right, this bicolor LED will turn green, and if you're wrong, it'll turn red. Then you would just press the reset pin and it would start again. So some people have better memories than others, which is why there is this 10K potentiometer here, because by adjusting this potentiometer, it adjusts the difficulty. And by difficulty, I mean how fast the sequence flashes. So the parts that were used were a 10K potentiometer for the difficulty, 5 bicolor LEDs to show the sequence and then replicate the sequence. These 4 switches, they are single pole, single throw. So you would push it and it would be, so say green right now, and then you'd flick it over to the other position, it would be red. This Omron momentary switch, so you'd press it and that would lock in your answer. This other momentary switch down here, which is the reset button. We have 5 220 ohm resistors, so 1 for each bicolor LED. We have 2 10K resistors and then 1 1K resistor. And in this corner is our voltage regulator. Because we used a 9-volt DC jack and this runs on 5, we had to put a voltage regulator in. This is the regulator here. This is a 1 microfarad capacitor, and this is a 10 microfarad capacitor along with our DC jack. And then this is our resonator. So because we're running the ATmega off of the Arduino, so it's just by itself, it needs a clock because it's a processor, so it needs to know, it needs like a sense of time. So this is our 3-pin clock. I have a link about this guy on my blog, so you can read it and you can read why the ATmega needs him. And so now I will give you an example of the game in action. So I'll plug it in and set this guy green. So these guys are always on, and we'll watch the sequence that flashes in this. So it's green, green, red, red. So we have green, green, red, red, and then we will lock in our answer, and it goes green because we got it right. So now if we do it wrong on purpose, so I didn't know. I didn't even keep track of that one. So I'll just set them all green, and I'll lock in, and it turns red because I'm wrong, because I didn't even pay attention. So that might be too slow for some people because people have different memories. So we'll turn it all the way up to the fastest, and we'll see how fast it flashes. Like, look at how fast that is. I don't even know what it is. So that's pretty much the project. I have sort of difficulties that I encountered during the exam on my blog. So like I said before, we had to breadboard it and solder it in 2 hours. So it was very tight on time. And that's about it. I have full parts list, I have pictures, I have the schematic. One of the challenges was the schematic, actually, because we were given an eagle circuit diagram, which there's a better picture on my blog, but just for now it looks like this. And this was one of the difficulties faced because of how Eagle is designed. And yeah, that's about it. So I'll have another video hopefully soon because I haven't finished my audio spectrum analyzer, but that's it for now. All right.